resistors connected in series, and on our previous lesson we derived a formula on how to get the total resistance of a circuit when we have resistors connected in series. Problem 1. The circuit below shows 3 resistors connected in series. We have resistor 1 whose value is 1 kilo ohms. We have resistor 2 whose value is 2 kilo ohms. We have resistor 3 whose value is 6 kilo ohms. And these resistors are connected to the source voltage whose voltage is 9 volts. And now we are supposed to determine Roman 1, the circuit resistance, Roman 2, the circuit current, and Roman 3, the voltage drop across each resistor. And now let us now begin with Roman 1, the circuit resistance, which is the same as the total resistance of the circuit. And from the circuit we have here, these resistors are connected in series, and the formula for getting the total resistance in series, we are supposed to add all these resistances. Now we have R1 plus R2 plus R3. I'm now going to substitute the values we have. Our R1 is 1 kilo ohms plus our R2 is 2 kilo ohms and our R3 is 6 kilo ohms. The total now we are going to have 9 kilo ohms. This is now the total resistance or the circuit resistance. On our Roman 2, we are supposed to get the circuit current, which is the same as the total current in the circuit, and which is given from Ohm's law. From Ohm's law, current is given as voltage over resistance. And if we are going to get now the total current, we must use now the source voltage over the total resistance. Let us now substitute the values. For voltage from the circuit we have 9 volts over the total resistance, the one we've gotten from Roman 1, we have 9 kilo ohms. Kilo ohms is the same as 10, you multiply by 10 raised to 3. Now that one will give us 1 milliamperes. On part 3 of the question, we are supposed to find the voltage drop across each resistor. Then it means we are supposed to find the voltage drop across resistor R1. Let us call this voltage as V1. Also, we are supposed to get the voltage drop across R2. Let us call this voltage as V2. And another one, we are supposed to get the voltage drop across resistor R3. Let us call this voltage as V3. Now, let us now find V1. V1, if you want to find now the voltage, you know that from Ohm's law up here, if you want now to find this voltage will be given as current times resistance. If now we are going to get V1, then V1 will be given as I times resistance R1. Now, for the current, since the 3 resistors are in series, they will be having the same current flowing through them, which is equivalent to the source current or the circuit current. And the circuit current already we have it up here, which is 1 milliamperes. I'm going now to substitute the values, whereby we have current to be 1 milliamperes, which is equivalent to 1 times 10 raised to negative 3, times the resistance R1, whose value is 1 kilo ohms, which is equivalent to 1 times 10 raised to positive 3. And now the 2 cancels out so that we remain with 1 times 1, whereby we have 1 volts. On V2 will be given as I times resistance R2. The current is the same, so we are going to use 1 milliamperes, which is equivalent to 1 times 10 raised to negative 3, times the resistance R2, whose value is 2 kilo ohms. which is equivalent to 2 times 10 raised to positive 3. And the 2 now cancels out, so that we remain with 1 times 2, whose value now is 2 volts. And on V3, we do the same. We are going to multiply current times the resistance now, R3. The current remains the same, which is 1 milliamperes, times the resistance R3, whose value is 6 kilo ohms, which is equivalent to 6 times 10 raised to positive 3. The 2 cancels out, so that we remain with 1 times 6, which is equivalent to 6 volts.